Hello students, I'm here again with another video from the chapter Electrochemistry, and in this video I'll be talking about conductance of electrolytic solution and we'll try to do some numericals related to this. So before moving into the main topic, so we should know the definition of all this term: resistance, resistivity, conductance, right? And this term you might have studied in physics also. So let us try to revise it once. Now let us first try to discuss what resistance is. Now this resistance is defined as a hindrance provided by a conductor in the passage of current. Now every substance provides resistance to the flow of electricity either to small extent or to the large extent, and the substance which offer greater resistance will allow less electricity to flow through it or to pass through it, right? Now, so what is the mathematical expression of it? So we know that, so resistance, this is directly proportional to the length of the conductor and inversely proportional to the cross-sectional area. So so this again, whenever this proportionality sign is removed, so a constant term has to introduce, right? And in this case the constant term is resistivity, which is denoted by rho. So or you will get rho is equal to L R into A divided by L. Now let us try to define this resistivity or constant of proportionality. So when your length is 1 centimeter for a substance and its cross-sectional area 1 centimeter square, then what would be your rho? This one will become equal to R, resistance. So how to define this rho? So it is your resistance, resistivity is the resistance offered by substance of 1 centimeter length with cross-sectional area equal to 1 centimeter square, right? So what are the unit for R? R is resistance, so ohm. Then A, the unit for A and all, so it is SI unit is meter square, right? But we are considering here as centimeter, so centimeter square, length centimeter, and rho becomes equal to ohm centimeter. Okay, now next, so your resistivity, it is the resistance offered by a substance of 1 centimeter length with cross-sectional area equal to 1 centimeter square. Now next, try to define what is this conductance. So it is the S with which your current pass through the substance, right? Now mathematically how we are going to write it? So your G is, what is G? It is reciprocal of resistance. Now what is your resistance? Resistance is rho L by A. So your G is now 1 by R into A by L. And what is the unit for your G? So it is reciprocal of resistance, so its unit is ohm inverse. Now let us try to define this reciprocal of resistivity, which is also called conductivity. So we can define this conductivity as, or specific conductance, which is generally designated by the term kappa. So it is a conductance of solution of 1 centimeter length with cross-sectional area equal to 1 centimeter square. So alternatively, so we can define this conductivity as conductance of a unit volume of solution of electrolyte. Okay, so mathematical term. So conductivity is a kappa and it is reciprocal of resistivity. Now what is resistivity? It is R A by L. So kappa is equal to 1 by R into L by A. Now this term, this ratio is constant for given conductor. So we call this term as cell constant. So again this can be written as, so your, what is 1 by R? This is your conductance into what is L by A? It is your cell constant. So kappa is your G into G star, where G star is cell constant, and this is equal to L by A, and its unit is centimeter inverse. Now what is the unit for kappa? It is your ohm. It is reciprocal of your resistivity. So ohm inverse centimeter inverse is the unit for kappa, right? So again this ohm inverse is Simon. What called Simon? So we can again write the unit for this as Simon, centimeter inverse. Okay, now next, so let us try so how to measure the this thing, okay, specific conductance or conductance of the solution is measured. Now, so this conductance, conductivity, right? We know conductance is reciprocal of resistance. Conductivity is 1 by R into L by A. Now, the value of this can be known with the known value of resistance, with the known value of ln A, isn't it? Now, how to find out this resistance for a conductivity cell? Now, that can be obtained from with the help of Wheatstone bridge. Right, and now the resistance can be obtained by the principle or can be measured by the principle of Wheatstone bridge method, which is shown here. Now it consists of your R4, R3, which are fixed resistance, R2 this is variable resistance, and this is your conductivity resistance from the conductivity cell and the detector here. Okay, now this R, which is variable one, we can adjust it in such a way that no current is flowing through the circuit. At that point, what happened, what we can write is, or so how the flow of electricity can be detected is through this detector. Okay, so the point where no electricity flow through the circuit, we call that point as null point. So at null point, what we can write as, the ratio of your resistance become equal. So this is your R1. Okay, so R1 by R2 becomes equal to R3 by R4. So this is the required resistance which you need to calculate, right? So R2 then becomes equal to R1 into R4 divided by R3. This is how your unknown resistance can be measured, and with the after this, so we can find out the value for K, and we can kappa, and we can find out the value for the conductance. Next, we will try to discuss molar conductivity. Now, your molar conductivity, it is your conductance of solution, okay, containing 1 mole of electrolyte placed between 2 large electrode at unit length apart. So, your lambda m, okay, so this is equal to kappa into your volume of your solution. So, your kappa is your conductivity of unit volume of solution, and lambda m is conductivity or conductance of V volume of solution. Suppose unit volume, you know that if cost of 1 pen is 5, so let this be 5. So cost of 100 pen kati huncha? So 5 into 100. So 100 pen means total, so this is your conductivity of volume V solution, and this is conductivity of unit volume. So now V, so your V is your volume of solution in centimeter cube containing 1 mole of electrolyte. Suppose if C is the concentration, okay, of your electrolyte, what is the unit of concentration? If it is in mole per liter, that is molarity, right? So what we can say from this? So we can say this is what equal to C mole of electrolyte, right, present in, so liter. So when you convert this to centimeter, kati huncha? Centimeter, 1000 centimeter cube. So C mole of electrolyte present in 1000 centimeter cube, right? So भनेपछि 1 mole means how much volume? So 1 mole of electrolyte is your equal to present in, so C mole means 1000, so 1 mole is your 1000 divided by C centimeter cube. So if C is the concentration of your electrolyte, so V kati huncha? V is your 1000 by C centimeter cube. So therefore, what is your lambda m? Lambda m is equal to kappa into 1000 divided by C. Okay, and what is the unit for lambda? So this is your kappa, right? It is in ohm inverse, centimeter inverse, right? This is in liter, is there mole liter, right? That is your centimeter cube. Now mole centimeter inverse cube. So what you can write this as? So you will get unit of this as ohm inverse, when this goes up, plus 3 minus 1 centimeter square, then mole inverse. So kappa is your conductivity, its unit is ohm inverse centimeter inverse, and concentration is your mole liter inverse. Okay, so with all this equation, now let us try to do one sum. Okay, now resistance of conductivity cell is filled with 0.1 molar. Okay, for this solution the resistance is 100 ohm. Now, and the resistance, again same cell, but we change the concentration to 0.02. So at that time the resistance will also change and becomes equal to 520 ohm. Now you need to calculate the conductivity, molar conductivity of 0.02 mole liter inverse KCl solution, and the conductivity of 0.1 mole liter inverse KCl solution is your given, which is 1.29 Simon meter inverse. Okay, now there are two cases. So just we change the concentration, the cell is same. Okay, in first concentration is 0.1, and second we change the concentration for 0.02. So the resistance also changed from 100 ohm to 550 ohm, 520 ohm. So conductivity of first cell is given with first concentration, it is 1.29 Simon meter inverse, and you need to calculate conductivity and molar conductivity of 0.02 mole liter inverse solution, KCl solution. Okay, so with the help of this, first we will try to find out your the cell constant, which is same for the both. Just now we derived the formula for kappa as 1 by r into G star. This is your cell constant, and it will be constant for the both, same for the both. So kappa here is your 1.29, okay, is equal to your r. How much is r? It's 100. 1 by 100 into G star. So therefore what is G star? It is 1.29 into 10 to the power 2. And what is the unit here? Now see, this is in meter, so you can convert this to centimeter, because whatever units we are taking into consideration here is centimeter, right? So you can convert this to centimeter. So you can write this as 1.29 into 10 to the power minus 2 Simon minus 2 centimeter. Okay, हैन, किनभने 1 meter is equal to 100 centimeter. So माथि जान्छ 10 to the power minus 2. So into 10 to the power minus 2, and the unit is, this is centimeter inverse, right? So कति पाउँछ? 1.29 centimeter inverse as G star, cell constant. Now what is your K2? So K2 is equal to, it is again 1 by R2 into G star, isn't it? Now what is R2? 1 divided by 520 into G star 1.29. So after dividing you will get K2 as this one. So this you can write as, shift this to after one digit, decimal, put this decimal to after one digit. Okay, so you can write this as 2.48 into 10 to the power 123 minus 3. And what is the unit? Simon centimeter inverse. Okay, now next you are asked to calculate lambda m. And what is lambda m? It is K2 into 1000 divided by C2. Right, now what is K2? How much we have calculated? Into 10 to the power minus 3 into 1000 is your 10 to the power 3, right? Divided by concentration is your 0.02. So these two will get cancelled. So 248 divided by 2. So lambda m is your 124 Simon centimeter square mole inverse. Okay, so again I am repeating. So you are given with concentration, resistance and kappa for the cell 1, and from cell 1, okay, from the concentration 1 you can easily calculate G star, and after calculating G star you can go to the another case, right? You put the value of G star in that case. So K2 is equal to 1 by R2 into G star, and from there you will get the value of K2, and it is 0.48 into 10 to the power minus 3 Simon centimeter inverse. Tesserine lambda m is your K2 into 1000 divided by C2. When you substitute the value, do multiplication division, you will get the value as 124 Simon centimeter square mole inverse. So these two are the required answer. Thank you.